Now that we see it, we have our sodiums. Both of those are also balanced. The calcium is balanced and the BRs are balanced. The only thing left is the OHs. And on this side, if I go back and recount, 2 times 1 is 2. 2 times 1, because this is like one thing on its own, we do not need a parentheses because there's no number behind it. So 2 times 1 is 2. Let's look. 2 and 2, 2 and 2, 1 and 1, 2 and 2. Then in that case, my whole equation is now balanced. Okay, let's keep going. Turn the page. Oops. Let's see. We have 1, 2, 3, 4, 5-ish left. All right, let's keep going. Here are the answers for the next practice problems. Let's see if I have any. Nope. Okay. Okay, so again, I gave you the answers here. We're about to practice in just a minute on the homework. I want you to kind of take a glance at it. Please write down the answers, and while you're writing down the answers, we're going to practice on the actual homework. That way, I have a homework here that's blank, and then you don't have to worry about the actual answers in front of you, right? We want to be able to do it and practice it on our own. So if you need to, pause it. What I will do though is I will come over here and I will come to number 9. Number 9 is not done, so let's practice that one now. First step again is, here's my arrow, so I'm going to go ahead and write down Li, lithium, H, and O. Yes, I have H2Os or H and O's on this side, and I have OH and H over here. But in this case, it breaks. It says here, trick, if you break water into H and OH, it is easier to count that way. So we're going to go ahead and break this H and O's apart, okay, because they're broken apart over here. It's not like if it's still grouped together. I'm going to go ahead and put my wall up, and let's count. 1 times 1 is 1. 1 times 2 is 2. 1 times 1 is 1. Let's count this side. 1 times 1, lithium, is 1. 1 times, I'm going to go ahead and do the O by itself. 1 is 1. 1 times 1 is 1. 1 times 2 is 2. Plus 2 equals 3. So let's see. 1 and 1, 3 and 2 and 3, and 1 and 1. So this H is where I'm at. I have a problem because it's not balanced. So we have to go ahead and let's start balancing there. Well, I've got too many H's over here, 3, and I have 2 over here. It's kind of like math class. You want to find that lowest number where they can both be multiplied by something, but yet we want to make sure it's as reduced as possible. The lowest common denominator kind of thing in math class. So we need to find a number that 2 and 3 can both kind of go into. What is something that they both can? But in this case, I have to go ahead and I'm going to count. What if, it's a lot easier. Let's go ahead and just kind of go up one number at a time. I don't want to go too high up to like a number 3 and a number 2. I'd rather just go up one number at a time. So if my number here was originally 1, let me just go ahead and go up the next number, which is 2. Okay, let's go ahead and recount this stuff over here. 2 times 2 is 4. 2 times 1 is 2. Well, now I'm off on the H's still, and I'm off on the O's. So let's look over here. What should I do? Well, I need to change the O's. Let me go ahead and change that first before I go back and mess with those H's. Okay? Let me go ahead and change this O to a 2 by putting a 2 here. So let's count it out. 2 times 1, I have to do the lithium again, is 2. 2 times 1 is 2. 2 times 1 is 2. But don't forget, there's another H over here. 1 times 2 is 2. So plus 2, which equals 4. Let's go ahead and look. 2's, check. 4's, oh my God, I'm getting closer. But the lithium, I need to mess with this one on this side. I need to change it to a 2. So if I put a 2 here, this becomes a 2. 2 and 2, check. 4 and 4, check. 2 and 2, check. Now we go ahead and fill in the rest with 1's. 2, 2, 2, and 1. That is the correct way to balance this equation. I love it. Okay. Let's go ahead and let's keep going with our notes. And you know what? Actually, we're going to pause for a moment. We are going to go to our homework first, and then we'll come back to our notes. So in our homework, let me find one. Trying to find a blank homework. It looks like this. Correct? It is practicing writing and balancing chemical equations. So it's what we've already been doing so far in our notes. I think we should pause for a moment, look at the homework, practice, and then we can go back to our notes again. I will give you the answers to the homework in just a moment, but I want to practice them first. Okay? So let's look at this first one. We have NaClBeF. So I'm going to go ahead and come over here on this side. I'm going to put NaCl because I don't have a lot of space to do it over here. BeNF. I'm going to put my wall. Here's the reactant. Here's my product side. Let's go ahead and let's start counting. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. 1 times 2 is 2. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. 1 times 2 is 2. I'm not balanced. I need to mess with the F and the CLs. So I'm going to go ahead and start on this side. The CLs need to become a 2. So let's put a 2 here. But we need to go ahead and recount everything. 2 times 1 is 2. 2 times 1 is 2. Now on this side, I'm not okay with the F. So I'm going to go over here and I'm going to put a 2. But I need to go ahead and start with the Na. 2 times 1 is 2. 2 times 1 is 2. Let's look. 2 and 2, yes. 2 and 2, yes. 1 and 1, yes. 2 and 2, yes. I'm going to fill everything else with 1s. Now I am balanced. I'm going to come over here. I'm going to skip down to number 5. Again, I will give you the answers. I just want to do some practice problems. I have Mg, M, N, and O's. Put my wall, reactants, products. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. I am not balanced. I need some more MNs and some more oxygens. Well, I'm going to go ahead and go with the oxygens. It needs to be 3. So if I put a 3 here as a coefficient, 3 times 1 is 3 for the Mgs. And the oxygens, 3 times 1 is 3. Well, my oxygens are balanced, but my Mgs are not. So I'm going to come back over here and make that a 3. There's nothing with other than the Mgs, so that's the only effect or change that it's going to cause. But I also see that I have, oops, let me get the light back on again. When I look at it, I see that the MNs, I need to have a 2. So if I put a 2 here, there's nothing with it. So here goes the only change. What's left over, I add a 1, and there's how it should look. Let me go ahead and give you the answers for the other ones. Here they are. Please pause the tape if you need to, so that way you can look at the answers. I would practice them first though. Okay, let's go ahead and let's continue. Down here. Okay, So let's look at this one over here. It's written in words, but it's best to go ahead and have it written out as an actual equation. So it says here that a solution of potassium bromide, okay, well, potassium is a K. It has a +1 charge. Bromide is a Br. It has a -1 charge. Is mixed with, that means that you're going to add it with, let's see, a solution of barium acetate. Okay. Barium has a +2 charge. Acetate is actually a polyatomic, C2H3O2, and it has a -1 charge. To form, okay, let's go ahead and do our yield sign, potassium acetate plus, or and, potassium acetate K +1 charge, acetate, again polyatomic, it is going to be C2H3O2 -1 charge, and barium bromide. That's going to have a +2 charge, and that's going to be a -1 charge. So the first step here is to, if it was me, I would write all my charges. The next thing I would do, if I have a polyatomic, I would write it down what it is plus the charge to go along with it. Now let's go ahead and write our skeleton out. Well, this is kind of like our skeleton. This is the beginning part of it. Let's finish writing it out. I'm going to have K and Br, crisscross those. They cancel out because they're both ones. So KBr plus, I'm going to have Ba for barium acetate. Crisscross those numbers. A 1 comes over here. So Ba, this 2 is going to come over, so I need to put parentheses. C2H3O2, parentheses 2, forms, that's going to be my yield sign. Crisscross those 1s, they cancel out. Let's go ahead and write that down. KC2H3O2. Do not put a parentheses around that polyatomic because this 1 comes over here. Plus Ba, Br2. This 2 crossed over, and that's why there's a 2 over here. Now we need to go ahead and see, are we balanced? And we're actually not balanced. Let me go ahead and do this here. I'm going to put K, Br, Ba, and since this polyatomic is the same on both sides, I'm going to write it as one unit, C2H3O2. Put my wall up. Let's go start off with our reactant. 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1, 1 times 2 is 2. 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1, 1 times 2 is 2. I'm not balanced. Let's go ahead and do the BRs. If I put a 2, that changes the K, potassium. So 2 times 1 is 2, 2 times 1 is 2. Now I'm not balanced over here. So let's go ahead and put a 2 in front of that. Now I can say that 2 times 1 is 2, 2 times 1 is 2 over here. Let's look, 2 and 2, 2 and 2, 1 and 1, 2 and 2. Look at that, I am balanced, I'm done. Since I wrote it out and there's no blanks or spaces, I do not need to put a 1 in front of those, okay? But let's go ahead and let me give you the answers for this practice problem as well as the copper reaction here. Again, I suggest that you practice it now on your own, pause the tape, then go back and check your answers. I just want you what's best for you to practice, okay? So pause it now. I'm gonna put the answers up. Oops, yeah, there you go. So here's the answers to the practice problem up here and to number 2. And we did number 1 together. Okay, we're going to keep going. If you need to, pause it so you can write the answers, but I'm going to move forward. There's some more practice problems. Let's do another one. Let's do this one right here. I'm going to go ahead and write it down. Zinc. Let's look. I have OH, H, H2O. For me personally, I'm going to go ahead and I'm going to separate the O's and the H's separately. That's how I like to do it. And then PO4, P, and I'm going to leave it as is. And the reason why I'm going to leave it as is I'm going to separate this polyatomic. Yes, there's a polyatomic here, but this polyatomic has oxygens, and the H2O or the OHs also have oxygens. I want to separate all my atoms separately. Okay? There might be some people who leave the polyatomic, I understand, but I'm going to go ahead and separate every single thing. Let's go ahead and count it out. First, 1 times 1 is 1. 1 times 2 is 2. Now this 2 goes to the O and the H. So there's 2 here, 2 here. 1 times 3 is 3. So 2 plus 3 is going to be 5. 1 times 1 is 1. And 1 times 4 is 4. So 4 plus 2 makes it a 6. Let's count this one. 1 times 3 is 3. 1 times 1 is 1. 1 times, well, this 4 and 2 need to be multiplied to an 8. So 1 times 8 is an 8 for the oxygen, but this 2 also goes to the P. So 1 times 2 is 2 here. Let's go ahead and look at the H's. 1 times 2 is 2, plus there's oxygens. 1 times 1 is 1. So that becomes a 9. It's kind of a weird, tricky one. That's why I wanted to practice this with you. So let's go ahead and let's look. Why don't we go ahead and work with the zincs? There needs to be a 3 over here, so let's put a 3 in. So 3 times 1 is 3, but we need to count up the oxygens and hydrogens as well. 3 times, well, this 2 goes to both of them. So this is 2 goes here. So 3 times 2 is 6. So 6 plus 6 is 12. And this 2 goes with the H. So 3 times 2 is 6 again. 6 plus 5 is 11. Where am I at? Let me go back and recount everything because I done stopped for a second and paused and lost track. 3 times 1 is 1. 3 times 2 is 6. Let me just do it this way. 6. And since I'm looking at oxygen, 1 times 4 here, because this 4 goes with the oxygen here. So there's no parentheses like this. So this 4 only goes to the oxygen. So 1 times 4 is 4. So this actually is a 10. So obviously I was off. There we go. So sorry. But there's a hydrogen that's being affected. So let's count this up and let's add this hydrogen. I don't know what I wrote here, but let's go ahead and rechange it. 3 times, well, this 2 goes here. So 3 times 2 is 6. Plus 1 times 3 is 3. So 6 plus 3 is 9. Who knows what I got earlier? Let's look. 3 and 3, 10 and 9, 9 and 2, 1 and 2. Well, let's go to the P's. I need to have that to be a 2. So let's put a 2 in front of this. But again, not only the P's, the O's and the H's are also going to be affected, so I should recount it. So let's start off with the H's. So 2 times 3 is going to be 6, plus over here, 3 times 2 is 6. So this actually becomes 12 for the H's. And the P's, 2 times 1 is 2. Okay, I'm looking better now. on the P's. And let's look at the oxygens. Once I do that, I need to add those again to make sure I get the right number. So 2 times 4 is 8 for the oxygens. But over here, 3 times 2, because this 2 is like factored in to H's and the O's. So 3 times 2 is 6. So this is 8. 8 plus 6. So 8 is 14. Becomes a 14. 3's are good. 10, 9, 14, 2, 2, and 2. Well, snap. We're not doing good just yet. I need some more H's on the product side. So 3, 2, H's over here. What if I come over here and put a let me recount this because I think this is actually incorrect, right? So when it comes to the H's, 3 times 2 is 6. I'm just going to put a 6 right here. And on this side, H's, 3 times 2 is 9. Uh, 10, 14, 17, 20. So in this case, I've got, for the H's, 3 times 2 is 6. Over here, this is OH, OH, so there's 2. 3 times 2. Why am I writing a 9 if it's truly a 6? Somebody, why are we not in class so that way you can tell me to stop? 3 times 2 is 6. Or you're probably at home telling me to stop. 6 plus 6 is 12. Where am I getting that 14? I had 12 originally. So now that I finally got my H's correct, 3's, check. Potassium's 2's, check. H's, I got 6, 12 over here, 2 over here. But on this side, here's my H's. If I put a 6 in front of it, 6 times 2 becomes 12. But wait a minute, my oxygen changes. So let's go back to this side. 6 times 1 is 6. So now I have 6 oxygens. Let's come back over here. 4 times 2 is 8 times 1. It stays to be an 8. So in this case, I got 5, 10, 13 plus 14 oxygens. 8 plus 6 is 14. I'm going to scratch those out. Snap. We're still on the same problem. 3 and 3, 10 and 14, 12 and 12, 2 and 2. I still need to do something with the O's over here. But if I come around, I've got 3, I got 2. Maybe I miscounted my O's. So let me go ahead and backtrack. 2 times 4 for my O's is 8. This 2 goes in here. 3 times 2 is 6. 5, 10, 13, 14. What in the heck? I had a 10 and I really should have had a 14. You're probably yelling at me at home. I understand. All right. All right. 3 and 3, 14 and 14, 12 and 12, 2 and 2. And you know how on the rule it says to make sure like you double check? Unlike me here, you should probably triple and quadruple check. Finally, 3, 2, 1, and 6 is the correct answer. That is the correct answer. I just wanted you to see that sometimes, you know, people screw up on accident by miscounting, because look at how many miscounts I did. But go back and double check and double check. I promise you, you're going to get to the right number eventually. The numbers here stay fairly small. For us to get a 6, that's a really big number. Okay? Let's pause it for a moment. Do the rest of your practice problems if you want to, but I'm going to go ahead and show you the answers, and then we're going to go back to our notes. Here are the answers. Okay, so there are the answers. Let's go back to our notes, and then we'll come back to the homeworks. Move this. Move this. Okay. We finished our notes there. It says, now let's get to what we call types of reactions. You already wrote it down, but let's go ahead and let's look at this part here. We've got a couple of different types of reactions. And one of them, or one of the important ones that we start off with, is what we call a redox reaction. Okay? So a reaction where atoms or ions transfer electrons always as a single element or either a product or reactant side of the equation. That's a key word right here. There's going to be a single element that's going to be involved. Okay? Well, I'll break this down to simplify this a little bit easier in just a moment. That's the definition of what a redox reaction is. It says here, oxidation numbers is the number of electrons lost or gained. That we know. Look at the periodic table and find the oxidation numbers for the elements and predict their charges, right? We know it's going to be a +1 or +2 or +3, plus or minus 4, -3, -2, -1, and 0. That's what it kind of looks like on the periodic table. It says here, free elements have an oxidation number of 0. Some of the oxidation numbers in a compound needs to equal 0. We're going to get to this and explain maybe a little bit more later. Let's turn the page though. And on this side, I broke it down. Get your pen out. I did not have this for you before. The 4 different types of reaction or the redox reactions are synthesis, decomposition, combustion, and single replacement. To simplify it, it's going to be synthesis. It's an A plus a B. They equal an AB. They're just added together. Decomposition, you have one thing, for an example, AB, and they're broken apart. They separate to an A plus a B. Combustion, you have AB together plus oxygen, right? Combustion like a fire, and you end up with AO plus BO. Next one, you have B plus C, which yields AC plus B. Let's look back. We have a single element. On this side, we have a single and a single. It does not matter if it's on the reactant or product side. If there's a single element, then we call that a redox reaction. This O2 is considered to be a single. Why? Because it's a diatomic. That's the reason why there's a 2 behind it, but it's still considered to be a single element. AB plus C equals C plus AC plus B. There goes single ones. Here's the breakdown over here. Go ahead and write it in. Is there a single element? There's either a yes or no answer. If it's a yes, then it's what we call a redox reaction. If it's a no, then it's what we call a double reaction or a double replacement. Now, redox, there's 4 of them. Here they are. We're going to have our combustion, which is O2, decomposition, synthesis, and single replacement. This is O2 for combustion. If it's a double replacement, then we're going to have an acid base or it's going to be a precipitant. All right, so let's go ahead and actually look at the type of redox reactions and then we'll go look at those double replacements in just a moment.